Imagine a gateway that could transport you instantly across vast distances of space and time. A bridge connecting galaxies, perhaps even universes. This isn't just the stuff off science fiction. It's a concept grounded in theoretical physics, known as a wormhole. But how much of this idea is rooted in reality in this exploration? We'll dive into the science behind wormholes, their potential existence, and whether they could ever transition from theory to practical application. What is a wormhole? A wormhole, sometimes called an Einstein-Rosen bridge, is a hypothetical tunnel-like structure connecting two separate points in spacetime. The concept arises from Albert Einstein's general theory of relativity, which describes gravity as the warping of spacetime by massive objects. Wormholes are solutions to Einstein's field equations, allowing for shortcuts through the fabric of the universe. Picture a piece of paper. If you fold it and punch a hole through both layers, you've created a crude representation of a wormhole, a direct path between 2 points that would otherwise require traversing the entire sheet. Theoretical foundations. The idea of wormholes has fascinated physicists and inspired countless stories. In 1935, Albert Einstein and Nathan Rosen proposed the existence of these bridges in spacetime. Their solution described a connection between two black holes, leading to the term Einstein-Rosen bridge. However, these early models had significant limitations. They were unstable and would collapse almost immediately. To keep a wormhole open, scientists theorized that it would require a form of exotic matter with negative energy density, something not yet observed in nature, but theoretically possible within the framework of quantum mechanics. Do wormholes exist? So, do wormholes actually exist in our universe? The answer is maybe. While no direct evidence has been found, the mathematics of general relativity doesn't rule them out. Some solutions suggest that wormholes could form naturally in extreme cosmic conditions, such as during the formation of black holes. Astronomers are continually exploring the cosmos for signs of these mysterious phenomena. Advanced telescopes and instruments might one day detect subtle gravitational effects or unusual light distortions indicative of a wormhole's presence. Can we travel through wormholes? The concept of using wormholes for travel, a staple of science fiction, is tantalizing. Imagine crossing millions of light years in moments, or even traveling backward or forward in time. But the reality is far more complex. To make a wormhole traversable, it would need to remain stable and large enough for objects, such as a spaceship, to pass through. This is where exotic matter comes into play. Without it, the wormhole would collapse before anyone could enter. Additionally, there are significant challenges posed by the immense gravitational forces and radiation near a wormhole. Even if one could exist and remain stable, traveling through it might prove fatal for humans or any other form of matter. Wormholes in popular culture. Wormholes have captured the imagination of storytellers and audiences worldwide. From the iconic Stargate in Stargate SG-1 to the emotional journey in Christopher Nolan's Interstellar, these cosmic gateways often serve as plot devices for exploring the unknown. While Hollywood's depiction of wormholes often bends the rules of physics, they've introduced millions to the wonders of theoretical science. They remind us of humanity's insatiable curiosity and drive to explore beyond our limits. Scientific breakthroughs and speculations. Recent advances in quantum mechanics and string theory have provided new insights into the nature of spacetime. Some physicists suggest that wormholes might exist on a microscopic scale within the quantum foam, a chaotic sea of particles and energy at thesemalous scales of the universe. If true, could these tiny wormholes be scaled up for practical use? The answer lies in breakthroughs yet to come. Research into quantum gravity, dark energy, and the unification of physics' fundamental forces may hold the key. Ethical and philosophical questions. The potential discovery and use of wormholes raise profound questions. Who would control such technology? Could it be used for exploration? Or might it become a weapon? And what would happen if humanity gained the ability to travel through time, altering the course of history? These ethical dilemmas underscore the importance of responsible scientific exploration. The power to manipulate space-time, if ever achieved, must be handled with great care and foresight. The future of wormhole research. As our understanding of the universe deepens, the possibility of unlocking wormholes becomes less far-fetched. Projects like the Event Horizon Telescope, which captured the first image of a black hole, and advancements in particle physics could bring us closer to answers. For now, wormholes remain a tantalizing mystery. They sit at the intersection of science and science fiction, inspiring both rigorous study and boundless imagination. Wormhole mechanics breaking it down. To understand how wormholes might work, we must explore the mechanics of spacetime. Imagine spacetime as a flexible sheet. A massive object, like a star or planet, creates a depression in this sheet, which we perceive as gravity. A wormhole would essentially fold the sheet, connecting 2 points with a tunnel. However, creating such a tunnel requires manipulating gravity and energy on scales we can barely comprehend. Exotic matter, a theoretical substance with negative energy, could theoretically stabilize a wormhole. Without it, the tunnel would pinch shut instantly. While negative energy might sound like science fiction, it has some grounding in quantum theory. The Casimir effect, for instance, demonstrates the existence of negative energy in the lab, albeit on a tiny scale. Time travel and paradoxes. One of the most intriguing aspects of wormholes is their potential to enable time travel, that if one end of a wormhole is accelerated to near-light speeds and then brought back to its original position, time dilation could create a temporal discrepancy between the two ends. This means stepping through the wormhole could take you into the past or future relative to your starting point. However, time travel introduces paradoxes. The grandfather paradox, for example, questions what happens if you travel back in time and prevent your own existence. Physicists debate whether such paradoxes could be resolved through alternatimalenes or self-consistent loops, where events adjust to avoid contradictions. The role of black holes. Black holes are often linked to wormholes in theoretical physics. Both involve extreme warping of spacetime, and some models suggest that black holes could contain wormholes at their cores. The event horizon of a black hole, the point beyond which nothing can escape, might conceal a passage to another part of the universe. However, the intense gravitational forces near a black hole would pose immense challenges. Any traveler attempting to enter a black hole's wormhole would face spaghettification, a process where tidal forces stretch objects into thin strands. Overcoming these forces would require breakthroughs in materials science and energy manipulation. Are wormholes the key to interstellar travel? Humanity's dreams of interstellar travel often hinge on overcoming the vast distances between stars. Even at the speed of light, reaching the nearest star system, Alpha Centauri, would take over 4 years. Wormholes, if feasible, could provide a shortcut, making interstellar journeys practical within human lifetimes. Organizations like NASA and private companies are exploring advanced propulsion technologies, such as warp drives and antimatter engines. While these approaches focus on bending spacetime locally, wormholes represent a more radical solution, one that could revolutionize our approach to space exploration. Cultural impact and inspiration. The allure of wormholes extends beyond science, shaping our culture and imagination. They symbolize the human desire to transcend limits and explore the unknown. From books and movies to art and video games, wormholes inspire creative expressions that blend science with storytelling. This cultural fascination fuels interest in real-world research, creating a feedback loop where science and imagination propel each other forward. As we learn more about the universe, our ability to envision and pursue the extraordinary will continue to grow. Wormholes represent one of the most exciting frontiers in modern physics. They challenge our understanding of reality, offering possibilities that seem both magical and scientific. While many questions remain unanswered, the pursuit of wormholes pushes the boundaries of what humanity can achieve. Whether they remain theoretical constructs or become practical tools for exploration, wormholes embody the spirit of discovery. They remind us that the universe is full of mysteries waiting to be unlocked, and that the journey of understanding is as important as the destination. As we stand on the cusp of new scientific breakthroughs, one thing is certain: the quest to unlock wormholes will continue to inspire generations of scientists, storytellers, and dreamers alike.